Okay, so we're going to start E2.7, which is combining functions. Before we get into that, we're going to take two functions and combine them into a new function, which can alter the domain. Okay, so I'm just going to refresh what domain and range is and what we need to look for when we're looking for excluded values or things that would make our domain smaller or our function undefined. Okay, when we're looking for a domain, we're basically saying we want to know every single possible value that we could plug into the function except those that make it undefined. Okay, and we have two restrictions that we're going to encounter in this class. Okay, there's more in life in general, but the only ones we have to worry about for our class are fraction domain restrictions and even root restrictions. Okay, fraction domain restrictions, we're talking about rational expressions. Okay, when we have rational expressions, we have to worry about the denominator. Okay, anytime we have a denominator, a variable denominator, meaning there's an x in the denominator, it cannot equal 0. So I'm going to put here the denominator, and I'll write it out. Denominator cannot equal 0. Okay, so all we're going to do is we're going to set our denominator equal to 0 and solve for the excluded values. Okay, now if they don't have a rational denominator, we don't have to worry about this. Okay, but if they do, this is how we're going to work it out. Okay, all right. The next thing we have to worry about is even roots. So if I had something like a square root of x, remember here we can't plug in negatives, right? Because negatives gives us imaginary numbers. So anytime we have an even root, since we can't evaluate an even root of a negative number, that gives us a problem. So to make sure that whatever's underneath here stays positive, we're going to set it greater than or equal to 0, because it can be 0 or it can be positive, but it can't be negative. Okay. One thing I do want to note is that whatever is underneath the square root, okay, is called the radicand. Okay. Everything under the radical is called the radicand. So to find even root restrictions, we're going to set the radicand greater than or equal to 0. Okay, and solve. So I'm just going to say set radicand greater than or equal to 0 and solve for excuse me, allowed values. Okay, so we're restricting our domain to only things that make the radicand positive or 0. That way we never end up with a negative value that we have to evaluate under a square root function. Okay, all right, so these are the two we have to look for. Sometimes we have restrictions, sometimes we don't have any restrictions. So we only have to worry about it if you see a denominator that has a variable or if you see an even root. If it's anything else, we don't worry about it. Okay, so let's go ahead and define our new functions that we get by doing algebra of functions. So here we're saying f and g are just two functions. Our new functions are a sum, difference, product, and quotient, which I'm going to write in terms of f and g. If I want to sum f and g, I write it as f plus g of x. Okay, and this is our notation. This is how we write it in MyMathLab. What this means is this is the same as just taking f of x and adding g of x to it. So combining like terms, okay? Possibly needing a common denominator, that kind of thing, but we're just basically combining the two functions into one, and that's our new sum function. Difference function is the same. I do f minus g of x, okay, which is f of x minus my g of x function. Make sure you write these in the right order or your answer will suffer, okay? And since we're subtracting, if there's more than one term in our g function, make sure you distribute this negative to every term of g. Our product function means we're multiplying, so f times g of x is the same idea. We're doing f of x times g of x. So if there's more than one term, we need to FOIL or distribute, okay? And then our quotient is f over g of x, which means I'm taking my f of x function and dividing my g of x function. Okay, and I'm going to put a little disclaimer here where g of x cannot be 0, okay, which we'll address that when we look at our domain. Okay, so these are our new functions. So now we're just going to look at an example. We're going to take f of x equals x squared minus 5 over 2 and g of x equals 6x, and we're going to find these new 4 functions by adding, subtracting, multiplying, and dividing them. Okay. Now before I do that, I always want to look at my domain of my original functions. So notice this f of x function, I do have a denominator, but there's no variable in it. So if there's no variable in it, I don't have to worry about it being 0. And there's no even roots. So here the domain of f is going to be negative infinity to infinity. Okay. Same thing with g of x. I don't have a variable denominator and I don't have an even root. So that means that the domain of g is going to be negative infinity to infinity. So here I have no restrictions on my original functions. So when I combine them, hopefully that will mean I don't have to worry about too many domain modifications. So let's go ahead and find each of these new functions and their domains. Okay. So the first one they want us to find is f plus g of x. So when I do f plus g of x, remember this just means I'm taking my f of x function and adding my g of x function. Okay. My f of x function is x squared minus 5 all over 2 plus my g of x function, which is just 6x. Okay, so that's all I had to do. Now in my math lab, it won't let you enter it like that. You have to enter it as a cohesive one piece. Okay, or in other words, we need to get a common denominator. So I'm going to go ahead and write the second piece as 6x over 1. And my common denominator for these two terms would be 2. So I'm going to multiply on top and bottom by 2, which will give me x squared minus 5 over 2 plus 12x over 2. And then I can combine these terms. Okay, which means that f plus g of x is the same as x squared plus 12x minus 5 all over 2. And I wrote it in descending order. Okay, so I'm going to leave it like that. The only other way you can enter this on my math lab and it'll allow it is if you break it apart and write each piece over 2. So if you were to enter this as like 1/2 x squared plus 6x minus 5/2, it would allow that as well. Okay, I'm not going to leave that on here though. I'm just going to leave it how it is. Okay, and then I want to find the domain. So when I find the domain, notice I'm combining a function that has all real numbers in its domain with a function that has all real numbers in its domain. So when I combine them, it should be all real numbers unless by combining them I created a variable denominator or I created an even root. So notice that when I look at my f plus g function, there's not randomly now a variable in the denominator and there's not an even root. So that means here the domain of f plus g is going to be negative infinity to positive infinity. Okay, let's look at another one. We did the sum function. Let's do the difference function. So now we're going to do f minus g of x, which means we're going to do f of x minus g of x. So again, I plug in my two functions. F of x is x squared minus 5 over 2 minus my g of x function, which is 6x. Now we already know, because we did this before, in order to combine these, I'm going to need a common denominator. So I'm going to go ahead and write this over 1, which means, again, I'm going to need to multiply on top and bottom by 2 so that these have the same denominator. So I get x squared minus 5 all over 2 minus 12x over 2. Okay, and now I can combine the numerators. And again, I'm going to write it in descending order when I combine. So I get x squared minus 12x minus 5 all over 2. Then I just need to list my domain. Again here, since I'm combining two functions that have a domain of negative infinity to positive infinity, I should still have that same domain unless I've incurred a new restriction by combining those. So here I have to check, do I have a variable denominator? Here I do not. And do I have an even root? Which again, I do not. So that means that the domain of f minus g is still negative infinity to positive infinity. Okay. Now I want to go ahead and try my product function, which means I'm doing fg times x, okay, which means I'm doing f of x times g of x. So I'm just multiplying the two functions. So my f function is x squared minus 5 over 2, and I'm multiplying that times my g function, which is 6x. Okay? Because I'm multiplying fractions here, I'm going to go ahead and write this as 6x over 1, and I'm going to go ahead and reduce. Okay? Remember, you can reduce common factors before you multiply as long as they're not stuck in quantities. So here I can say 2 goes into 2 one time, 2 goes into 6 3 times. Okay? Which leaves me with x squared minus 5 times 3x. And then again, we need to go ahead and multiply it out so it's simplified. So this gives me 3x cubed minus 15x. So this is my new product function. And the domain on this one, as you can guess, is still going to be negative infinity to infinity because I don't have a variable in a denominator. I don't even have a denominator. And I don't have an even root. So that means that the domain of fg is going to be negative infinity to infinity. Okay. And then I have one last one, which is my quotient. So I'm going to do f over g of x, which remember means I'm dividing. So f of x divided by g of x. So I'm putting my f function on top, which here is x squared minus 5 all over 2 divided by my g function, which is 6x. Now here this is a complex fraction. We can't leave it like this. So I'm going to go ahead and write this as 6x over 1. Okay? And remember, this division, this fraction symbol, just means divide. So when I divide fractions, I flip and multiply by the reciprocal of the second. So this is the same as x squared minus 5 all over 2 times 1 over 6x. Okay? I don't have anything that I can cancel, so I'm just going to combine these. So I get x squared minus 5 all over 12x. So this is my quotient function. But notice I do have a restriction here on my domain because now I have a variable denominator, okay? And remember, our denominator cannot equal 0. So I'm just going to work it out over here. That means that 12x cannot equal 0, which if I divide off my 12 means that x cannot equal 0, okay? So I'm starting out with negative infinity to positive infinity being my domain, except I need to exclude 0. So that means that my domain of f over g is going to be from negative infinity to 0, right? Because I have to take 0 out. And then from 0 to positive infinity, okay? So I need to take out the excluded value, which here I only had an excluded value because I ended up with a variable denominator, okay? All right, so on all of these, we started out with 2 functions and we created 4 new functions. So in other words, we had x's in our functions, and when we created our new functions, we still have x's. What we're going to look at now is taking these new functions and actually evaluating them, meaning we're plugging a number into them. So if I go to this next page, this next example, okay, notice I'm not just doing g of x and f of x. I'm doing g plus x of 1, okay, or negative 1. So it's not just an x, I'm actually plugging in a value. When I'm plugging in a value, there's 2 ways we can work this out. One, when we find f plus g of x, of negative 1, okay, I could go ahead and find this function. I could do what we did on the last page. I could do f of x plus g of x and create a new function and then plug the negative 1 in. Or I could go straight back to the definition of a sum of functions. When I sum these functions together, this just means I'm doing f of negative 1 plus g of negative 1. Okay? So here I just need to plug negative 1 into my f function, see what it equals, plug negative 1 into my g function, see what that equals, and then add my 2 results together. So that's how I'm going to work it, because it ends up being a little bit easier that way. So I'm going to figure out f of negative 1. If I plug negative 1 into my f function, I get 6 minus negative 1 all over 2, which when I simplify, my double negatives become positive. So f of negative 1 is just 7/2. Okay. G of negative 1, when I plug negative 1 into my g function, g says to do 2 times the square root of the opposite of my input. So I'm doing the opposite of negative 1, which my double negatives here become positive. The square root of 1 is just 1 times 2 is 2. Okay. So again, I'm just going to rewrite this. We're trying to find f of negative 1 plus g of negative 1, which we just figured out those two values. F of negative 1 is 7/2 plus g of negative 1 is 2. Okay. And then I just need to get a common denominator. This is the same as 2 over 1, which if I multiply that second fraction by 2 on top and bottom, I have 7/2 plus 4/2, which gives me 11/2. Okay, so f plus g of negative 1 is 11/2. So these are actually a little bit easier because we're not ending up with a new function. We're just plugging in to actually get an answer. Okay, so evaluating is a little bit different than coming up with a new function. All right, so we've done this one. Now we need to do this one. So we're going to do f minus g evaluated at negative 1. Okay, which when I plug in negative 1 into both of these functions, I'm going to do it by the definition. This means f of negative 1 minus g of negative 1. And the good news is, remember, I already found these. I already did these over here in this teal color. So I know that f of negative 1 is 7/2 minus g of negative 1, which is 2. So I'm going to go ahead and write that as 2 over 1. And again, just like before, get a common denominator. So I'm going to multiply on top and bottom by 2, which gives me 7/2 minus 4/2, which is 3/2. So here, f minus g evaluated at negative 1 equals 3/2. Okay. So the good news is if they're evaluating these functions at the same value each time, we only have to plug it in once, and then once we know those numbers, we're just adding, subtracting, multiplying, and dividing them. Okay. So let's look at our multiplication, our product function. F times g of negative 1 means I'm doing f of negative 1 times g of negative 1. So when I plug in the values, remember that I found here in teal, that means I'm doing 7/2 times g of negative 1, which is 2, and I'm going to write that as 2 over 1. Okay. So notice here I can go ahead and reduce. My 2's cancel. 2 goes into 2 one time, 2 goes into 2 one time, which when I work this out leaves me with 7 over 1, which is just 7. Okay, so f times g evaluated at negative 1 is positive 7. All right. And then the last one I have to do is my quotient, f over g evaluated at negative 1, which remember just means f evaluated at negative 1 divided by g evaluated at negative 1. So when I plug in those values, this means I'm doing 7/2 divided by 2. Okay? And I'm going to go ahead and write this as 2 over 1 because we have a complex fraction, so we need to flip the second one and multiply. So we have 7/2 times 1 over 2, which gives me 7/4. Okay? So we've done ones where we have f of x and g of x, and we create a new f plus g of x. Okay, we create a whole new function, or sometimes they'll just give us values, and we're just plugging in to evaluate those new functions. Okay, here's another way of doing it. On these that we just did, they gave us an equation or a function to plug in the x to get the y answer. Okay, what we're going to do on this next one is instead of giving us a equation to plug into, they're giving us a picture to plug into. So notice each one of these is being evaluated at negative 1, which means I need to know what f of negative 1 is and what g of negative 1 is. So that's the first thing I'm going to do. I'm going to figure out what is f of negative 1 and what is g of negative 1. Okay, f of negative 1, remember function notation, whatever's in here is the x, and whatever it equals is the y. So I'm trying to figure out what is the y value when x is negative 1 on the f curve. Okay, so I go to where x is negative 1, which is here, and I trace it up until I hit my f function. Here my f function is the absolute value, this v function, and its y value at that point is 3. Okay. Then I do the same thing with g of negative 1. I go to where x is negative 1. I trace it up to my g function, which is this parabola, which also ends up hitting at the same y value of 3. Okay. So now that I know what f of -1 and g of -1 are, I can work out all these evaluated functions they wanted me to find. So the first one they want me to find is f plus g of -1, which means I'm doing f of -1 plus g of -1. So f of -1 we found is 3 plus g of -1, which is 3, which gives me 6. Okay. Then they want us to find f minus g of -1. So that means I'm doing f of -1 minus g of -1. F of -1 is 3 minus g of -1, which is 3, which gives me 0. Okay. Then we want to do our multiplication, our product, f times g evaluated at -1, means I'm doing f of -1 times g of -1, which will give me 3 times 3, which is 9. And then the last one I have to worry about is my quotient. So f over g evaluated at -1 means I'm taking f of -1 and dividing that by g of -1, which in this case means I'm doing 3 over 3, which equals 1. Okay, so we use our picture to figure out our output, and once we know our outputs, we just add, subtract, multiply, and divide them. Let's look at one more like that. This function over here, we're doing the same thing, same values. So before I get started, I want to figure out what f of -1 is and what g of -1 is. Okay, so I go to where x equals -1, which in this case is here, and I'm going to trace it down to my f function, which here is a square root because we have a little half parabola, and its y value where it hits the f curve is at -2. Okay. Now I do the same thing with a g. I go to where x equals -1, trace it up to my g curve, and its y value at that point is 1. So now that I know what f of -1 and g of -1 equal, I can figure out the 4 things they were wanting me to find. So the first one is f plus g of -1. So I'm doing f of -1 plus g of -1, okay, which when I add those, f of -1 was -2 plus g of -1, which is 1. -2 and 1 gives me -1. Then I'm going to do f minus g of -1, which means I'm taking f of -1 and subtracting g of -1. F of -1 was -2 minus g of -1, which was 1, which gives me -3. Again, make sure you write these values in the correct order, because when you subtract and divide, order does make a difference. Okay. I'm going to do my product next, f times g of -1, which means I'm doing f of -1 times g of -1. So I'm doing -2 times 1, which gives me -2. And then the last one I do is my quotient, f over g of -1, which means I'm taking f of -1 and dividing that by g of -1. So I'm doing -2 divided by 1, which again gives me -2. Okay. All right. So on the next page, there's 2 for y'all to try, and I'll give y'all a minute to work on that, and then we'll go over them. Okay. All right, so on this first one, we're finding the 4 new functions, the sum, the difference, the product, and the quotient. When I do the sum, I should get -3x squared plus 2x minus 2. I didn't have any new domain restrictions, so my domain stays -infinity to +infinity. Okay. On my difference, make sure you distribute that negative to both terms of g. Okay, which leaves me with 3x squared plus 2x plus 4. Again, I did not incur any new domain restrictions, so my domain of f minus g is -infinity to +infinity. Okay. On my product functions, I'm multiplying, so here I need to FOIL or distribute, whatever your choice is, and then make sure when you rewrite it, you write it in descending order, meaning the highest power of x term down to the constant term. Here again, we did not incur any new domain restrictions, so my domain stays -infinity to +infinity. And then the last one we have is our quotient function, which means we're dividing our 2. Notice here, you don't have to do like polynomial long division or anything like that. Just put f of x over g of x. Unless you have a complex fraction, I'm not worried about you simplifying it. Okay, there is one problem here. Notice all terms in the denominator are negative. When all terms of the denominator are negative, MyMathLab sees this as a negative in the denominator, and it won't let you enter a negative in the denominator. So if you find yourself with a denominator where all terms are negative, either factor that negative out and write it up front, or move it to the top. So here I'm going to write it as negative 2x plus 1 over 3x squared plus 3. Or if I distribute the negative to the top, I get negative 2x minus 1 over 3x squared plus 3. Okay, either one of those is acceptable. And then I need to look for my domain. Notice here I have an x in the denominator, so I have to worry about the denominator equaling 0, which is bad. So I go ahead and set my denominator equal to 0 and solve. Notice when I solve for my excluded values, I get imaginary numbers, which we're not plugging in imaginary numbers. We're only talking about what real number values can we plug in for x. So here, since it says I can't plug in plus or minus I don't even care. Plus or minus I is not in my real number domain. So here I have no domain restrictions, so my domain will be from negative infinity to positive infinity. Okay. On the second one, we're evaluating, which means we're plugging in numbers. So the first thing we find is f plus g of 2, which means we're evaluating f of 2 and g of 2 and then adding those together. F of 2 gives me 5, g of 2 gives me negative 15. When I combine those, I get negative 10. Okay. When I find f minus g of negative 1, again, find f of negative 1, which here is negative 1, find g of negative 1, which is negative 6, and then I'm subtracting them. Make sure you subtract them in the correct order. If you get f and g switched, it's going to change your order. So here I get negative 1 minus negative 6. My double negatives become positive, which gives me a 5. Okay. And then I'm doing f times g of negative 1, and I've already evaluated each one at negative 1. I know that f of negative 1 is negative 1, g of negative 1 is negative 6, so I just multiply those together, which gives me positive 6. And then the last one is my quotient. I'm evaluating my quotient function at 0. So I plug 0 into f, which gives me 1. I plug 0 into g, which gives me negative 3. And then I just divide those, okay? Again, make sure you can't enter a negative in the denominator. So if you end up with 1 over negative 3, either stick that negative out front like I did here, or put the negative up top with a 1, okay? All right, let's keep going. The next thing we're going to go over is the difference quotient. Okay, the difference quotient is f of x plus h minus f of x all over h. One thing I want to point out so that you don't freak out with the difference quotient is this is really the only piece that you're going to have to find. Okay, you're going to have to find this piece because this piece, notice, is just the original function. Okay, original function, and h is just always going to be h on the bottom. Okay, you will have to know the difference quotient. So if I tell you find the difference quotient of this function, you'll have to know that the difference quotient is f of x plus h minus f of x all over h. Okay, so let's go ahead and look at one. This one says find the difference quotient for the function below. Okay, we always simplify as much as we can. So the first thing I need to figure out is f of x plus h. So remember, when we evaluate functions, whatever's inside the parenthesis is what we plug in where we see an x in our function. So since x plus h is in my parentheses, I'm going to plug in x plus h everywhere I see an x in my original function. Okay, and then I just simplify. So I'm going to distribute my negative 3, which is negative 3x, minus 3h minus 5. Okay, so this piece right here is just this piece that I boxed in up here on my difference quotient. So I'm going to go ahead and write my difference quotient is f of x plus h minus f of x all over h. Okay, so we just found this piece right here. So I'm going to go ahead and plug that in. So that piece is negative 3x minus 3h minus 5, and then I'm subtracting. Okay, this is just my original function. So I'm going to plug in my original function, which here is negative 3x minus 5. Since there's more than one term, I'm going to use parentheses and put the whole thing over h. Okay, and then I just simplify. I'm going to distribute this negative and combine like terms. So I get negative 3x minus 3h minus 5. When I distribute that negative, I get positive 3x, positive 5 all over h. Okay? And notice now I have opposites. Negative 3x and positive 3x combine to 0. Negative 5 and positive 5 combine to 0, which leaves me with negative 3h over h. And then I can just reduce my h's, which leaves me with negative 3. Okay? So again, quick rehash. I'm just figuring out this first function, f of x plus h, and then plugging it into this difference quotient by subtracting my original and putting the whole thing over h. And then it's just a matter of simplifying. Okay? So let's look at another one. Here again, we're finding the difference quotient. So I'm going to go ahead and write over here my difference quotient is f of x plus h minus f of x all over h. So I want to find this piece first. So I'm going to do f of x plus h, which remember, anything that's inside the parentheses gets plugged in everywhere you see an x in your original. So I'm going to do 2 times my input squared minus my input. Here my input is x plus h. Okay? So first thing I need to do is FOIL out this term. Remember, when you have a squared quantity, that means you have the quantity times itself. It does not equal x squared plus h squared. Okay? So I'm going to go ahead and distribute out that quantity. X times x is x squared. X times h is xh. H times x is xh. And h times h is h squared. And then this whole thing is multiplied by 2. And then I have this minus x plus h out here. Okay, so I'm going to distribute the 2 and distribute this negative. So I get 2x squared plus 2xh plus 2xh plus 2h squared minus x minus h. And then notice I have like terms here that I can combine. So I have 2x squared plus 4xh plus 2h squared minus x minus h. So this answer that I just got here is just this first piece of my difference quotient. Okay, so I'm going to go ahead and plug that in. So I have 2x squared plus 4xh plus 2h squared minus x minus h. And then the next thing I do is I subtract my original. Okay, so I'm going to subtract my original function, which here is 2x squared minus h. 2x squared minus h. I'm sorry, minus x. Minus x. Okay. All over h. Are you okay? Hang in there. Okay. Now it's just simplifying. So I have 2x squared plus 4xh plus 2h squared minus x minus h minus 2x squared, when I distribute that negative, plus x all over h. Okay, and then I just reduce my common terms. So 2x squared and negative 2x squared combined to 0, negative x and positive x combined to 0, which leaves me with 4xh plus 2h squared minus h all over h. And I just said h about 4 times. So that means they all have h's. I can reduce 1. So I'm going to go ahead and just factor out an h on top, which leaves me with 4x plus 2h minus 1 all over h. And then I can reduce those h's, which means my difference quotient is 4x minus 2h minus 1. I'm sorry, plus 2h. Okay, so a quick rehash. We figure out what that one piece is, that f of x plus h, which is what I did over here on the left. Once we know that piece, then we just plug it in, subtract our original, divide it by h. So it's just a big simplifying problem. Okay, let's look at one more. Okay, this next one, same thing. I want to find my difference quotient, so I'm going to go ahead and write it, write it over here. Once my mouse comes back. All right, so I have f of x plus h minus my original f of x all over h. So first thing I want to do is find this piece. So if I plug in f of x plus h, remember whatever's inside the parentheses goes in wherever I see an x. So this function tells me to do -1 over 2 times my input. Okay, and I'm just going to leave it like that when I plug it in. I'm not going to distribute that 2 because I'm not sure if that's a good idea yet or not. So let's go ahead and plug that in. So I have -1 over 2 times x plus h minus my original function, which here is -1 over 2x all over h. Okay, so one thing I see right away is I have double negatives. When I have double negatives, I can go ahead and make that a positive. And then the other thing I notice is I need a common denominator in order to combine these. Okay, my x plus h can't be separated, it's a quantity. So for my common denominator, I'm going to need that x plus h, I'm going to need the 2, and then I'm also going to need an x because of that second denominator. So here my least common denominator is going to be 2x times x plus h, which means my first term I need to multiply on top and bottom by x. Okay, my next term I would need to multiply on top and bottom by x plus h. Okay, so I'm going to rewrite what my terms look like. This first term, x times -1 is -x all over 2 times x plus h, plus my next one I'm doing 1 times x plus h, which just gives me x plus h all over 2x times x plus h all over h. Okay, and now I just need to combine. I know it looks horrible, hang in there. So I get -x plus h all over 2x times x plus h all over h, which is good because notice my x's are opposites. So those go away, which leaves me with, screw it down so I have more room, which leaves me with h over 2x times x plus h all over h. Okay. And again, we still have a complex fraction, so I'm going to write that as h over 1 so that I can flip and multiply. Okay, so this gives me h over 2x times x plus h. When I flip and multiply the bottom fraction, I get 1 over h. And then notice I can go ahead and reduce here. Okay, I have an h on top and an h on bottom. So my final difference quotient answer is 1 over 2x times x plus h. Okay, I know it's super fun. Okay, figure out what f of x plus h is, plug it in, subtract your original, put it all over h. And then after that, it's just simplifying. Okay, all right, so there is 2 for y'all to try. I'll give you a minute and then we'll go over them. All right, so on this first one, we take our f of x plus h, which when we plug in x plus h, we get 6x plus 6h plus 2. Plug that into our difference quotient, subtract our original, make sure you distribute this negative to both terms of your original. Okay, once I do that, my 6x's and my 2's cancel, and I'm left with 6h over h. My h's cancel, so I just get 6. Okay, on the second one, same idea. I plug in f of x plus h, which gives me 1 over x plus h. So I plug in 1 over x plus h minus my original, which is 1 over x, all over h. Then I need a common denominator in order to combine my numerator. My common denominator would be x times x plus h. So I multiply the first fraction on top and bottom by x. I multiply the second term on top and bottom by x plus h. Okay. So now that they have the same denominator, I can go ahead and subtract across. I went ahead and used parentheses, so remember to subtract, distribute that negative to both terms of the second fraction, which leaves me with x minus h, so my x's cancel. So I get negative h over my common denominator all over h. Since this is a complex fraction, I wrote my denominator with a denominator of 1 so that I can flip and multiply. Okay, I reduce, which leaves me with negative 1 over x times x plus h. Okay, all right, so that should be the end of your E2.7 assignment, the first one, which is Algebra of Functions. You have another assignment from E2.7, which is about combining functions, and I'm going to go over that next. Okay.